right, thank you. All right, so hello, I'm Caroline Carter. I've had the privilege of working with Dr. Liu. Our project is photobiomodulation enhances blood oxygenation and tissue metabolism by near-infrared and laser light emitting diodes. Don't worry, it's quite a lot of words. There we go. So our overview. NASA is launching their Artemis mission in 2024. And this is really important for us because that means astronauts will be in outer space for a very long-term time. And we believe that PBM can have vast effects to help mitigate the notably negative causes of long-term spaceflight. We have various methods and materials and results in conclusion. Please keep in mind these key words. We have photobiomodulation, which is PBM, light emitting diodes, which is LED, and the word chromophore, which I will explain. So NASA asked us to create not only a portable, lightweight, but an effective, non-invasive treatment to help treat the adverse effects of microgravity, specifically with muscle atrophy. PBM is able to offer these effects. So PBM not only can come in different forms of light, so as infrared laser, but an LED as well. It also has a vast range of wavelengths. Let me get my pointer out. Yes, and so we chose 808 because it is a very common wavelength. We've also chosen 852 because it is very novel and there's a very limited research done on it. Muscle atrophy occurs in space very rapidly. It occurs at a rate of 20% within the first couple hours, which is very dangerous for most astronauts, and it causes them to have a minimum workout time of 2 hours per day. The Scott-Kelly twins is a great example of this. Scott Kelly went to outer space while Mark stayed on Earth. Scott experienced not only physical, but genetic differences and changes caused by long-term microgravity. He did unfortunately experience the muscle atrophy, as well as growing 2 inches taller, but that can also be due to lack of strain and stress caused on the muscles and the bones. All right. So what is PBM? PBM is a light stimulation on a tissue, which can be illuminated with an infrared laser or LED. Its function is to improve hemoglobin oxygenation and blood flow. It increases tissue oxygenation consumption. So the key questions we wanted to really answer was which wavelength was the optimal to use, and was it feasible to use LED for PBM? LED is notably less expensive, but it's also less effective than an infrared laser. And so those were some very key concerns. Our background and hypotheses. So aim 1 was to use PBM to quantify 4 different chromophores, and we're looking at 2 different wavelengths, 808 and 852. Aim 2 was to demonstrate if these chromophore changes can be caused by LED compared to sham. Sham is the same as placebo. Aim 3 was to compare these chromophore changes, specifically hemodynamic and metabolic changes, between the 2 light sources, because we wanted to see if these changes were independent of the light sources. A chromophore is a light-absorbing molecule and is found all over the body. The ones we are specifically looking at are deoxygenated hemoglobin, HB, oxygenated hemoglobin, HBO, total hemoglobin change, HBT, and the only metabolic chromophore we're using is cytochrome C oxidase. So when the light is stimulated onto the skin, it penetrates through the muscles and into the bloodstream. The muscles have notably ATP and mitochondria. Also, that's where CCO lives. CCO is a byproduct of the electron transport chain, and it creates a need for more oxygen. And so then the red blood cells that supply the oxygen become more oxygenated, which thus goes back into the muscles, and then they consume the oxygen. And we believe that this mechanism is what could potentially be used in space to help lower the amount of exercise time that astronauts need to use. Our experimental setup. Here is my mentor demonstrating the probe that we used. Here is when we used laser light stimulation on the probe. These 2 wires here are the sensors that we'll be talking about. And then in graph C, we have the LED being shown on the probe as well. In graph D, we have the power density meter. So the laser light was being shown through the skin of the wrist and detected at the bottom because we wanted to measure the amount of power density truly being shown by the laser and the LED. So we have a consistency between the two powers. Unfortunately, LED notably does have a lower power density than that of laser. Continuing on. Okay. And so our hardware system is that we use the McNair system. Here shown is the laser aperture. The laser aperture is very important for this because it can keep the light not only Gaussian, but also collimated, which means it is powerful in the center and less powerful on the outside. Here we have the graphs where we show the laser treatment. We have two circles here because we did it on both arms, but only one circle was used per treatment. Next, here is the tungsten lamp system. It's a graphical created by my mentor. And so it shows exactly what is going on. So the laser light is being shown on the side of the arm right here. And this is located just below the elbow. And so the tungsten light and the sensors are attached to the probe, and then it picks up the raw signaling from the laser and is exported to our computer. The softwares used were OceanView, which is a raw data signaling processing, which is great for us. So we can collect hundreds of data points within the first 15 minutes. Then we used a curve fit analysis program in MATLAB. And then we exported everything into Excel to do statistical and graphical analysis. We had to do what is known as t-tests and quartiles in order to filter out any motion artifacts. A motion artifact is when a human twitches or moves. It's natural within the body, but it is, unfortunately, a big source of error. Here is aim number 1. Let me move this. The difference between each chromophore, these are the chromophores, between 808 and 852 nanometers. In graph A, we have HBO. In graph B, we have CCO. Graph C is HB, and graph D is HBT. Please keep in mind that this is the key. So 808 is noted as the solid line, 852 is the dotted line. All colored is the stimulation, and the black lines are sham. And so you can see through all of these graphs that the error bars are so close that they're overlapping. And we found that statistically that there were little to no differences between each wavelength. The red block is the stimulation time, and the white is the non-stimulation time, so pre and post. For aim number 2, we wanted to quantify each chromophore between LED and sham to see if LED did produce any quantifiable changes, and in fact it does, which we noted here. And it's very important because it shows that there is a difference between stimulation in LED. Moving on, our third aim was to look at each chromophore between LED and laser. Remember, for this one, we wanted to make sure that the effects were independent of the light source. And what we found was actually very significant. So laser is the solid line and LED is the dotted line. We found that there is about a 50% power density difference between laser and LED. But for all 4 graphs, they do have a very similar graphical increasing change, which was very important for us. So for our discussion, as stated for aim number 1, we were able to show that there is a difference, but a very, very small difference between 808 and 852 created by PBM. Aim number 2, we showed that LED does create a difference between stimulation and sham. And finally, we showed that at the same wavelength, so 808 was the only wavelength we used for aim number 3, between laser and LED, there was a 50% power density difference and chromophore difference between those and that of laser. And so here's what we conclude that's happening. The increase of CCO, so it needs this metabolic change, it needs more oxygen, and that causes the hemoglobin oxygenation to increase, so the red blood cells bring more oxygen. And then HBT total, the oxygen is consumed by the muscles and therefore are more productive. So in conclusion, we saw that PBM enhances the blood oxygenation and tissue metabolism by both laser and LED diodes. This chromophore data that we collected is quantifiable, and it's very important to the scientific community because it's the only quantifiable data collected with 808 and 852. And also, we believe that PBM can have vast potentials for mitigation of muscle atrophy. For future work, we would like to have a larger population size because unfortunately, due to COVID regulations, we had to have a very small N of 10. We would also like to compare multiple wavelengths, including my mentor's previous work, which is 1064. We want to do more post-stimulation data, and that can help us determine when does the effects of stimulation are relieved from the body. And later, we just need to do more clinical research in general. These are our sources, and this is my acknowledgements. We would like to thank not only the McNair program, but Dr. Pruitt for his assistance and the entire research team. All right, thank you so much. Are there any questions?
Actually, great job, Caroline, but I have a question. I don't think it's clear. So why do we want to use LED if you say LED does not give us the same power as laser?
That is a great question. So we do want to use LED because it is not only cost effective for NASA, it also, due to its power density difference, so it has lower power wattage, which does create lower effects in the body, but over time can be used as the same quantifiable results. But we'd like to use LED as a good option compared to infrared laser, because obtaining a laser is not only very difficult, you have to go through multiple approvals, it's also very expensive.
And bulky.
Yes. Yes, thank you. Are there any more questions? Wonderful.
Well, sorry. Hello, Caroline. I would just off that. So, like Dr. Liu was saying, what is the size difference between the units? So, which one would be more viable for them to take on to spaceflight? Would it be the laser or the LED?
That is a great question. So we believe it would be LED because it has a more compacted unit. The laser is not. No, I don't think I have a photo of it, but it's a very large unit. It has to have a very high power source and it must be plugged in. And NASA really wanted something smaller and more portable, also less heavy. And unfortunately, laser is quite heavy, it is larger, but LED is more compact and has very simple wires that can connect to it.
Right. And do you need any protective equipment to use the LED, or is that only the laser? Oh.
So due to it being at these infrared wavelengths for both LED and for laser, these infrared wavelengths can be very harmful for the eyes. And so we do wear very certain goggles for all procedures, just in case, because the light can cause damaging effects on the eyes. But when used specifically on the area of the muscle, there's very small negative effects on the body itself. It's just for protective wear.
Okay. But did we wear the goggles for LED measurement?
We had the subjects wear the goggles, just in case anything would happen. And for LED, I believe we did wear the goggles, just as a protective measurement. And leakage is unfortunately it can occur from the light because the light is going through an optical cable. Any breakage or split in the cable can cause the light to come out of the cord and could potentially be dangerous. So we wore them just as a protective measure.
Well, so for the LED, it shouldn't be required, but you just did that for protection's sake, right?
Yes, that is correct.
Oh, okay, got it.
Just for the public information for all others, for LED, the protection goggles are not required, but for laser, we have to require everybody to wear goggles. So that's part of the reason. it's much more convenient to use LED under any conditions. I'm going to add this observation because her time is about to be done. And really thank you very much for all this McNair's program. Natalie, thank you very much for all of your work and all others. She, meaning Caroline, is very impressive and she learned things quickly and she's particularly very organized. She's helping me to organize the study and then get our subjects coming in and then do the measurement with a very detailed planning, and then she learns things very fast. As you can see, her presentation is at the professional level. I just told her a few times to change a few things, then she